Welcome to the Okay, I'm gonna relax. Welcome to the hyperbolic coding. Welcome to the hyperbolic suffering chamber. We are back once again. It is day 134. Tough times. Tough times. My brain feels like it has gone through. My brain feels like a basketball, but the used basketball, the kind that when you bounce on the basketball court, it just doesn't quite bounce the same. My brain is fried. We are in DEFCON 3 mode. I feel like watching all the intros back to back is going to make me seem very, very strange, but this is all to say, my brain is tired. I am tired. But maybe I should view this as a chance to go even further. They say that we grow at the furthest limits of our capabilities. So maybe if we push through this, we'll be rewarded with more executive function and or a longer or more fuel efficient tank. So yeah, my brain is fried. I think there's a few things that probably has to do with that. Probably the problem this week, the min cost climbing stairs problem, just kind of sat on my front brain, kind of like the whole week. Work has definitely taken a lot of brain power, and also the schedule is a little bit all off. So I've been doing LeetCode after work, but I'm pretty fried after work. So it kind of takes a bit more than usual to do the LeetCode, which bleeds into the next day. So we pretty much need to start doing it back in the morning again. That's when the schedule was going well. But yeah, maybe we should view this as a chance to perform. So some of my best sessions have been when I thought I wasn't going to do very well and we started frying. So maybe that's what will happen this session, but unlikely. So we shall see. We shall see. Nonetheless, my brain is fried. I feel like I want to do a 30-minute session today, but I'm still going to do an hour anyway. So we have some comments. I'm feeling definitely super low energy. We have a comment from Suman Pandit. Your problem solving skill, fire. Your comment making skills, fire. Love you, human. Yeah, we finally solved. Oh yeah, I forgot to say. Okay, we got to redo the intro. Yesterday is why we do LeetCode. So yesterday I was solving a problem. It was very difficult. Couldn't figure it out. And then, lo and behold, we were able to figure out the solution. And I feel like it's those moments. I think there was another day, maybe around day 88. We had a similar thing. I solved the problem and it was like stark proof. I would never have been able to solve this problem X days ago. And the same goes for the problem we solved yesterday, min-cost climbing stairs. That problem has been the bane of that concept. The conceptual corner that problem lives in has been the bane of my existence. There's a lot of similar problems, climbing stairs, coin change, snakes and ladders, shortest path problems. All these problems will now be fried by me. In the future, if I ever run into them, it's going to be a mix on site. So maybe we should go back to those problems to fry them. But yeah, those are the days, those are the reasons why we do LeetCode. It's just a beautiful thing to see when it happens. That is the goal. Also, the Discord bot is proceeding well. It should be ready soon. So pretty much the whole thing of the Discord bot, kind of wanted to build a community of people who are trying to work at LeetCode and just problem solving. But we do LeetCode because that's what everyone does. And to me, I just view it as a vehicle to practice, focus, and also just to get good at something. So would be cool to track it. So the Discord bot just tracks that in Discord. Hopefully that'll be pretty cool. But it's pretty much ready. I just have to, there's a database on it. So I just have to make sure there's a database reversion method in place in case something goes awry. And then we should be ready. We have another comment from T. Wong, the GOAT, the God King, the God Prince, the legend himself. I don't 100% agree with you. Taking minimal hints are good, but the problem is you need to know the fundamental data structure and algorithms beforehand. We are not here to invent things like two-pointers, union find, and etc. You need to learn and know about them before trying to tough out problems without hints. Facts. I think this is facts. So, to be honest, I think we're aligned 100% on this answer. I think when I was answering yesterday, I probably just neglected to include some nuance. But yeah, I 100% agree. I definitely don't think it's Flames to go in blind with no hints. But I definitely think it's possible on some of the easier problems. But yeah, I don't think there's much to beat there. But I think we're pretty much aligned. I agree. Definitely want to know some of the fundamental structures before going without hints. So this is true. Also, make sure to check out T. Wong the God. We need some more LeetTubers. So that's pretty cool. But we are back once again. It's not cool, actually. Not joining the HCC. So there we go. That's what's not cool. Not joining the HCC. So you're going to want to join the Hyperbolic Coding Chamber as soon as possible to make sure that you have access to the latest GPT 3, 4, 5, and the unreleased 6 instances, as well as Stability.ai's new diffusion and imaging model. We have access to all of these in the Hyperbolic Coding Chamber. We are 400 million strong right now, so you want to click the link in the description to join before the queue gets too long. So, I'm not really certain what day it is anymore. Maybe we need something to automatically count the days. Also, I was thinking it might be cool to stream this, but we shall see about all of these things. But the thing we will see about the soonest is LeetCode. So we are back once again to solve more problems. I think we were working on valid palindrome, but we were stuck upon a case. It looks like you need to do at least linear time. It seems like we need to do at least linear time to make this make sense. We wrote an algorithm which was n squared time, which was LeetCode said no. Stop it, get some help. So we'll have to figure out a way to make this make sense in a time complexity that is not disrespectful to LeetCode servers. So I'm going to run this again, but I'm pretty sure if this doesn't work. So I'm relatively certain this version works. I'm only certain because we're able to pass around 430 out of the 469 test cases until we get to this one. So is there a better way? We're pretty much given a string s, return true if the s can be palindrome. That's just the sentence is broken. Statement has a typo, which is broken the brain. Given a string s, return true if the s can be palindrome after deleting at most one character from it. So it seems like we pretty much need to be able to test whether or not if we remove a character, can it be a palindrome? We wrote another version that checked the structure of the palindrome, or if it could categorically be seen as a palindrome, but that did not, or structurally seen as a palindrome, but that did not include the order in which the strings were actually in, the characters were in. So that was not ideal. Wait, an is palindrome function. What have we tried so far? So let's just write this down. We tried is palindrome with ignore IDX. The result was time limit exceeded. We tried another version, structural palindrome check. Didn't consider string order. So in that version, we might return true for something like A, B, B, C, because you could remove A And structurally, this could be a palindrome, but if you read it forwards and backwards, it's not a palindrome. It doesn't seem like this problem has any hints. What if we combine these solutions? So we have a structural palindrome check, which didn't consider the string order. Whereas the first one has TLE. The first one checks literally every character. Well, it tries to ignore every character and checks if it is a palindrome. First time it runs into that value, which is a palindrome, it returns true. What if we could optimize the process in which we choose the indexes to remove or to ignore? Then our worst case time complexity would be a constant times n rather than n squared. How could we know if removing a string would optimize? Doesn't seem like the way. Optimized version could be nonsensical. So structural palindrome check, we didn't consider the string order. What if we tossed both versions out? I can't see a version of this that doesn't compare the string going forwards and backwards. That's how you check if something is a palindrome. We're checking if something is a palindromic value. How could we do that? Return true if the S deleting at most one character. Which characters would that be? Which characters could that be? Which character could those be? Is palindrome. It says one of the potential methods is two pointers. The regular palindrome check is already 2 pointers. So even if we were to use 2 pointers, how does this, we're already using 2 pointers. Maybe we need to use 3 pointers. We tried a version where we counted the number of errors. Which is what would happen if we skipped what happened if we ignored when they don't match. For example, we can return true here because we could delete the character B, get ACA, or we could delete the character C and get ABA. Now, why didn't that version work? Yeah, why didn't that version work? I know it's here in our submissions. Maybe it's because the errors that we were counting didn't include a skip to make it make sense. For example, if we had something like this, A, E, B, B, C, the only character you can remove to make this a palindrome is E. But when we do our palindrome check, we compare A and C. Wait, no, we have to turn to A. Compare A and A would be good. Then we compare E and B, and we'd have an error. When we move forward again, we would compare these two, B and B, and it still would be itself. So actually, that doesn't make any sense. What if we put E at the front, A here? So if we compare A, right, this is what I was trying to say. If we compare E and A, we get a false, right? That's one of the errors. We'd continue forward, and now we'd be comparing A and B, which is not what we want to do. We want to be comparing B and B together. The reason I think we can't do that version is because we'd have to know which side, either left or right, to match to, or which side is actually, which side to skip forward 1 index. So I guess what we could do is say, if left and right don't equal each other, right, then we can check. We can say, hey, if instead we use the left plus 1 and they match, right, then we'll add 1 to the error and then skip left over 1 to make it make sense, and then we'll keep going. That way we'll kind of be taking the locally best solution. We could still return true here. So let's see. So let's try it with this. If we do A and A, we're good. If we move left forward 1 and right down 1, we have B and C. Now these two don't match, so what can we do? If we move left forward 1, they do now match, and that would give us an error that it was okay for us to make. So I actually think we could make this work. I think we can actually just remake this based on the code here. It's basically the is palindrome function It's basically the is palindrome function. We have CT, except we'd have CT equal to, oh no, not CT. Errors equal to 0. Then we'd have left is less than right. We're going to take out this nonsense. And then if left is not equal right, this is where we're going to do some special logic. The first thing we're going to do is errors plus equal 1, because it is an error. It is indeed an error. But the other thing I have to do is to figure out which way to shift the 2 pointers to make certain that we keep moving forward towards the end while letting go of while not breaking the pairwise comparison. So one way to do that is to say if s sub left plus 1 equals s sub right, then we'll just say left plus equals 1 instead. It's like we'll pretend that we compared it with that character. Otherwise, we do if s sub left is equal to s sub right minus 1, then we'll do right minus 1 instead. And in the else case, if neither version would fix it, that's a tough problem to solve. Now, if neither version would fix it, like in this case with A, B, C, if we do A and C, it's no palindrome. B and C is no palindrome, and C and A is no palindrome. There's no way to fix this because 1, we already have 1 error, and 2, I think we can just return false. Oh man, literally the last 6 test cases. So there's clearly something here that we're missing. So we have FF, CN, CN, Q, CN, 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 QX, QX, and JJ. Somewhere here we're missing it could just be the case that we mentioned before. Maybe we're just returning false. Maybe we're not checking every possible case. If left plus 1 is equal to s sub right, what if s sub left as it is equal to s sub right minus 1? Okay. This is interesting. You know what? I'm going to print the characters that didn't match. Or we can just print left and right and s sub left and s sub right. Now this is a bit ghetto, because ideally we'd think through why. So you have 21 and 80 P and C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19. So here we have LUC, and here we have LCU. So we have LCU with the proper reverse being UCL. So the both L's match. And if we take a look at C, if we take a look at both L's match, we can either say, okay, S sub left plus 1, which is U, does it equal to S sub right? No, it's equal to U. So what if we say S sub left, which is C, is it equal to right minus 1, which would be U? Wait, no, we're at C. So if we add 1, is U equal to C? No. Now we do it the opposite. What if we say if C wait, this should work. Is it this one right? Wait, I'm confused. We have P and C. Wait, so it's P here. I think we can shorten this whole thing by just doing LCUP and P. They had UCL, except we want to swap these. Something seems off here. What if instead of printing S sub left, we'll just print S dot substring. We'll do at left minus 3. And then we'll do the same here. Except since this is going down, if we want to take a substring, take the last 3, and then here we'll do S dot substring, except we'll start at right. We'll start at right minus 3. Now we want to take this one, the last 3 characters, we want to take this one to the last. So we'd actually do write plus 3. So then we should find that case where we failed to complete it. So we have L cup, and we have U sol. So if we ignored C, I see. So I think we should be able to properly recreate this now. It's that the characters already exist. But our version should catch this, which is what I don't understand. Check L and L, they match. Then we get to C and U, they don't match. So we check if left plus 1, which is U, matches S sub right. It does, so we do, the path we take is suboptimal. So you take left plus 1. And it would have been better This doesn't seem that simple. If we look at L cup versus I have a better idea. What if, as soon as they don't match, we just check if we ignore one of these substrings, is it a palindrome? While checking if it's a palindrome while going through. If we do it that way, as soon as we find that C and U don't match, we'll check if we can make a palindrome starting from C and skipping U. And if the answer is yes, which it is, then we can return true, because if we remove a character, it'll be fine. Now we can check the other way. Now, if either of those are true, we can return true. Otherwise, we'll just return false. We can remove errors. And we'll say is palindrome, right? And the string we're going to pass in is palindrome is going to be a substring starting from the left, right? But ignoring the first character, going up to and including right. It should include right, even though the end is exclusive. Or is palindrome. This time we'll start from left, which is inclusive, and then we want to, so in the left hand side here, the value that we're skipping is actually the value on the left in this. The character we're skipping is going to be on the left hand side because we're adding one. In the right hand side, the way we make it work, we'd want to skip the right hand. So we can just pass in is palindrome with right s dot substring here will return true. Nice. Very interesting. I feel like our solution is still a bit ghetto since we're checking if it's a palindrome while going through, but as soon as they don't match, we just check, hey, can we check if it's a palindrome by removing one of these characters from the left hand to the right hand side, and if we can, we return true, otherwise we return false. The worst case time complexity of this would be linear time. So iterating through the string, which technically is n over 2, but it's just going to be n. And then if two characters don't match, from there we're going to run as palindrome, which is one more linear time complexity in the worst case. So I want to say it's linear time, but let's see how they solve this. Actually, I wonder if we could make this faster. Okay, so they end up I guess it's oddly satisfying. We ended up writing the same exact solution. Mismatch pair, they check if it's a palindrome by shifting the ends. So we end up with linear time and constant space. So at least we know that we're on to something at least. So we'll cancel this problem, and then we have given two integers num1 and num2, return the sum of the two integers. Wait. Let me see. Maybe this is too simple. Turn the sum of the two numbers. 12 and 5, we get 17. Negative 10 and 4, we get negative 6. The numbers aren't out of massive, so we don't have to worry about anything like big ints. Okay, so I guess that's a throwaway problem technically. And we have remove palindromic subsequence. This one looks like it's going to be a bloodbath, particularly because it has a large number of dislikes. So it remains to be seen. You are given a string S consisting only of letters A and B. In a single step, you can remove one palindromic subsequence from S. Turn the minimum number of steps to make the given string empty. Okay, so we're given a string S consisting only of letters A and B. In a single step, you can remove one palindromic subsequence. Subsequence means they don't have to be contiguous. You just have to be able to remove them without changing the order. One palindromic subsequence. Turn the minimum number of steps to make the given string empty. String is called palindrome if it is one that can say backward. So, given a string S, it can only be A or B, and we can remove one palindromic subsequence from S, return the minimum number of steps to make the given string empty. S is already a palindrome, so its entirety can be removed in a single step. We want to return the minimum number of steps to make the given string empty. And on each step, we can remove one palindromic subsequence. So the first palindromic subsequence we try and remove is A, and then we remove B and B. Move palindromic subsequence BAB, then B. This problem seems kind of beastly. You turn the minimum number of steps to make the given string empty. we went outside in, if we went outside in, that would be a mess. If the whole thing is a palindrome, you can just remove the whole thing. I feel like since we're worried about subsequences, we can ignore the order and have and we'll have a special case for checking if something's a palindrome. I feel like since we're worried about, I didn't even think my head. I feel like since we're only worried about subsequences, we can just ignore the palindromic property. Otherwise, if we don't ignore it, it would definitely become I feel like it'd become a shortest paths problem. Not directly because we're looking for the minimum, but we can always phrase the minimum as the shortest number of, or the path to the goal state with the shortest number of vertexes. I think we could do this in s cubed time. In n cubed time if for each iteration we would ignore the index pretty much, or pretty much we would say, hey, what's the largest palindrome for each index in the array? What's the largest palindrome we can create? Now, how would we check that? Let's say we have access to index A. We could say start this index, create a palindrome. Now we go to B, make another palindrome except ignore B. Another palindrome except, oh, this includes the entire string though. Never mind. This problem is seeming kind of beastly. Subsequence. Or if we just write down potential ideas. Shortest paths. Seems clunky. Doesn't seem like the right way to go. Can we brute force? If we think of brute forcing it, unclear. Main issue is that it's unclear how we would brute force it. Also, it seems like it'd be n to the n. At least the way I'm thinking about it. Could do also hash map right? And we could take groups of, we could take occurrences, pretty much mod 2 as a step. What's the problem with this? Problem ignores, only includes this problem with this one is it ignores non-single letter palindromes. Ignores non-single letter palindromes. Problem ignores non-single letter palindromes. I think I see how this one has downvotes. I'm trying to corral my mind into thinking of solutions that are simple, but the only way that seems to make sense would either be something a little more involved. Like, this seems possible if I were to be able to mix I can't see a version of this that's not absolutely a mess. Pretty much we're given a string that consists of only A and B, and then we're pretty much allowed to remove a palindromic subsequence from the string each round. Or it can be non-sub. It could also be not be a subsequence. What's the minimum number of subsequent palindromic subsequence removals required to make the string empty? What if we generated a graph of all the subsequences? If we generated all the subsequences we could remove, well, that might just be impossible as well. If we remove a subsequence like A, does it change to subsequence B? Well, maybe not. But if the subsequence we generated, which is not a subsequence, ABA, wait. Does it have to be? Oh, no, it doesn't have to be a palindromic subsequence because you can remove this entire string. We'll have to do some more thinking on this one. These high-level rated easies can be very difficult. Okay, well, we'll have to see. Think about this one some more. If we generated all the subsequences, that wouldn't be very fire. If we generated all subsequences and all palindromes, we can pretty much see everything as a subsequence. If we move, I think we figured it out, or something of it. If you look at subarrays, which are contiguous linked elements, then this problem is difficult. But if we see every palindrome in the string as a subsequence, because not every subsequence every subarray is not a subsequence. No. Every subsequence is not a subarray. But every subarray is a subsequence. So what if we see every palindrome as a subsequence? We could do this if we load it in a map. And I think that's all the time we have for today. So I'm just going to finish up here.